Okay. Somebody tell me what is one thing we learned last class? Yes. Solutes and solvents. And what is the solvent? Okay, that is doing the dissolving. And somebody else tell me, what is the solute? Yes, the substance that is being dissolved, right? We talked about, our example was salt water, okay? Somebody tell me, what is another thing we talked about last class? Yeah. We went over Lewis dot structures, yes. Yes. Okay, yep. Yep. Miscible and immiscible. Any rug? Beautiful. That was I was really hoping somebody would say that. Okay, and Anurag, can you tell me what that is?
It's like when an ionic compound, like the two, it splits into two ions in like the solvent, like a polar solvent.
Say that again?
Like when an ion splits into its two separate ions in a polar solvent.
So when it's dissolved,
yeah.
Okay, it separates into its ions. Now, remember I really emphasized something last class. Does anybody remember what I emphasized for dissociation? Is dissociation the same thing as dissolving? Can something dissolve but not dissociate? And what was that example? Say it. Sugar. And why does sugar not dissociate? Because it's covalent. And do covalent compounds have ions? No. Okay. Now, the reason why I said I was happy Anurag said that is because first part is, remember last class when we illustrated the dissolving process for substances, okay? If we had to draw those pictures every time, it would get annoying. And you would probably end up with arthritis in your hand. Instead, we can show a dissolving equation. An equation that shows the dissolving process without drawing out the entire structure of the substance. You will notice that these look very similar to when we did net ionic. Who remembers net ionic equations? Anybody? What was something that you always had to have when you wrote out your net ionic? What was one thing you had to have? The charge, so that's the first one. Okay, and what is another thing that you always had to have? The state. Now, why did I put AQ here? And not, like, S? Joey? Yes, because aqueous means that they're dissolving in water. Jake, what were you going to say? Okay. Means they're dissolving in water, right? So they're splitting up. We're not going to have, did we ever split up our solids? No. Some of y'all did, but you weren't supposed to. Okay. But no, you're not supposed to. So, we have a few possible scenarios for dissolving equations. First one is all soluble ionic compounds completely dissociate into ions when they dissolve. When we show our equation for this process, we will show the dissociation with a one-way arrow. So right here, one-way arrow. Now, I have these highlighted because I know sometimes if it's not like bolded or anything, we may not read the things that are in the pictures, but it's always important to read everything. I promise, if it wasn't important, we wouldn't write it down. Just like if it wasn't important, I wouldn't write it down, okay? So it says right here, if you are not sure, so if you are sure about the initial state, you can put it. But if you are not sure, you need to leave it blank, okay? And that's just for the initial state. However, if I give you the initial state, you obviously need to write it down. But if I don't give you the initial state and you do not know the initial state, you need to leave that blank. And I say that because if you then just guess, I will take points off if it's wrong what you write. However, you should always put a charge in a state of aqueous on the dissolved ions. That is required. Okay? You must have a charge and a state of aqueous for your dissolved ions. Okay? That was for, well, you do the same thing for other ones, but that was what we were talking about when we're talking about soluble ionic. Next part is for acids and bases. Strong acids and bases completely dissociate. They completely dissociate into their ions. So we show the dissociation with a one-way arrow. So you can see right here, HCl, it's hydrochloric acid. Okay? This is what the arrow should be. I see that it didn't print. Hydrochloric acid is a strong acid. And right here, I have a table that says, how do I know what's a strong acid or a strong base? You have to have these memorized. You have to know that if you're working with a strong acid or a strong base, it is going to completely dissociate, and you have a one-way arrow. Okay? Weak acids and bases only partially dissociate, forming an equilibrium, so we show them with a two-way arrow. So I have this right here. This is one way to show a two-way arrow. This is another way to show a two-way arrow, or this is a third way. It's either one. Like, you have three choices of a two-way arrow. These are all two-way, but pick your poison, whichever one you want, okay? So, I told you again, these are your strong acids and strong bases. So, if it is not on here, and it's an acid or a base, then you consider it to be weak. Bless you. Bless you. Does everybody hear that? If it is not a strong acid or a strong base, then every other acid or base is considered to be weak, which means you would have partial dissociation with a two-way arrow. Okay? And you can see that. Here's your two-way arrow right here. Hydrofluoric acid is weak. All right, next one. While soluble covalent substances dissolve, they do not dissociate into ions. So while we can write out a dissolving equation, it looks a little strange. So you can see this is sugar. Sugar, before you put it in water, is a solid. You then put it in water, and we all agree that sugar does dissolve, but it's just now aqueous, showing that it dissolved in water, but it did not break up into its ions. Does everybody see that? The difference between this and this. Okay? Finally, if a substance is insoluble, there is no dissolving equation. Sounds pretty self-explanatory, right? What does insoluble mean? It does not dissolve, right? Which means there cannot be a dissolving equation. Okay? So, we will use a symbol I, looks like this, lowercase I, to indicate the number of particles formed when a substance dissolves. So for strong acids, strong bases, and soluble ionic compounds, this will be the number of ions that are formed during the dissolving. Weak acids and weak bases will only partially dissociate, so we will not discuss I for these substances. Okay? For polar covalent substances which dissolve in water, I is always equal to 1, since they do not dissociate into ions when they dissolve. All right? Questions on this? All right, we're going to actually do some. Okay. First one, nitric acid. Pranavi, is that an acid, base, ionic, or covalent? It's an acid. Now, because we know if it's an acid or a base, what is another piece of information we should figure out too? Strong or weak, okay? So, Jake, is this strong or weak? No. Strong. What is the formula for nitric acid? HNO3. Right? We gotta remember our formulas. Seriously, like you have to. Right? And this is not on Jake, like Jake, star student. Okay? Would this be soluble in water, Austin? Why? Well, are weak acids and base soluble in water too? Yes. The reason why it's soluble in water is you could just say because it's an acid. And acids are aqueous, which means they dissolve in water, right? All right, so my dissolving equation. Again, this is another reason why it's important that you know your formulas. So I have HNO3. Now, on the first page right over here, it said, if you're sure about the initial state, you can put it, if not, leave it blank. Do we all know the initial state here? Yes. Aqueous. Now, because this is a strong acid, what does my arrow look like? Is it one way or two way? One way. Okay. When this dissociates into its ions, I have hydrogen with a positive 1 charge, which is aqueous, plus NO3 with a negative 1 charge, which is also aqueous. Now, anytime I write out a reaction, what should I always check? Not charges, balanced. Is it balanced? Obviously, you should check your charges because you got to write it correctly. But is it balanced? Well, is this one balanced? Yes. Okay. And the reason I say that is because, if you remember on this page, the number of ions that are formed is your I number. How many ions did I form? 2. So that's my I. Okay? All right, let's do the next one. Garima D. Your last name doesn't start with a D, though, does it? Okay, thank God. Bromous acid. Acid, base, ionic or covalent? Acid. Now, is this strong or weak? What is the formula for bromous acid? If you don't know it, don't ask your friend, just tell me. Remember, I ate something icky all night. I was nauseous. So bromous acid is saying, I'm talking about bro what? Mite. Bromite is Br O2, the charge of -1. So this is HBrO2. Is that strong or weak, Garima? Weak. All right. Ruhi, soluble in water? Okay, so again, here's my equation. Do we know the initial state for this? Yes, but if we didn't, what would we do? We just leave that. Now, Advaith, what is my arrow, one way or two way? Two way, why? Because it's weak. All right, Fiona, what is my first ion that I dissociate into? Hydrogen with a charge of +1, aqueous. And my second ion that I dissociate, not Ruhi, Satvik. Say it out loud. Because I know what bromide is, but some people in here might not. There you go. What do I always have to check? If it's balanced. Is this balanced? Okay, so what is my I? Well, it is technically 2, right? Because of that. But what do we say? What does it say here? Weak acids and weak bases will only partially dissociate, so we will not discuss I for these substances. But if we were, it would be 2, but really, we're not going to discuss it, okay? Did everybody hear that? Okay. Just wanted to go back to your notes so that way you could see. All right, let's do the next one. Strontium hydroxide, Elise. Hydroxide. It is a base. Is it strong, weak, medium? It is strong. Okay. Priya, is this soluble in water? It's a strong base. Yes. All right. Ayushi, how do I write strontium hydroxide? Say it loud. What do I need around the hydroxide? Parentheses, so SrOH2. Okay, this is aqueous. Is this a, Ashley, is this a one-way or two-way arrow? One-way. Okay, so this dissociates into Sr with a charge of positive 2, which is aqueous, plus OH, negative 1, aqueous. Shiloh, what is my I value? Where'd you get the 3 from? Because it's not balanced. It was a trick question I just asked her. Very good. You passed. What do I have to do to balance this? Put it 2 here. Right? Now it's balanced. So now, when I asked Shiloh what was the I value, she said 3. Did everybody see that? You always got to check to make sure it's balanced. It's not always going to be balanced. Trust me. All right, lithium phosphate. Vidyuth. Acid, base, ionic, or covalent? Ionic. So when I determine that something's ionic, Miley, what do I have to check? Would you like to phone a friend? All right, who's going to pick up? Gavin? Oh, this is like the easiest question either. When things are ionic, no, when things are ionic, hold on, Vidyuth. We have to check to see, is it soluble in water? And when I need to check to see if something's soluble in water, what do we use? The solubility chart. So flip back on your paper, and Miley, I want you to tell me if it's soluble in water. Bless you. Alright, that didn't sound very confident. It is. Why is this soluble in water? Anybody? Group 1. Lithium is in group 1. Always soluble. No exceptions. Alright. Lithium phosphate. Nathia, how do I write lithium phosphate? You don't need parentheses. P4. Yep. All right. Do we know the state for this? What? Well, no. How can something be aqueous and then dissolve in water again. It is solid. Now, most of you said aqueous, and let me explain, because I think some of you are confused why it's not aqueous. What we did here when we said soluble in water was just figuring out when I take my compound lithium phosphate and I place it in water, will it dissolve? We said yes. But lithium phosphate is not aqueous, because that means dissolved in water. Does everybody understand that? So your initial states can either be solid, liquid, or gas. Okay? Remember that first day when we talked about the different types of solutions you can have? So, again, this is solid, but some of you did not know that, so what should you have done? You should have just left it blank, okay? Chit, what arrow is this? One way or two way? Very good. So when this dissociates, we have lithium with a charge of +1, aqueous plus phosphate, PO4, -3, also aqueous. Arav, Janav, how many, what is my I value?
4.
How did I get 4? Because I only see 2. So where is my coefficient going? Very good. So when I balance that, then I end up with 4. Okay? Alright. Calcium sulfate, Maddox, acid, base, ionic, or covalent? Ionic, very good. Adaline, is this soluble in water? Everybody should be checking. We should not be waiting for Adaline to spoon feed us the answer, because I promise you she will not be doing that for you on your test. No! So guess what? Why did I draw that line and say, pew? It's not dissolving. This is what you should have gotten. Once you look it over, I want you to give me a thumbs up if you got that. Thumbs in the middle if you got, maybe you just missed one thing. Thumbs down if you just don't even know what day of the week it is. Whatever. Stop it. Do we have any questions about these 3? Okay. Again, these bottom 3, obviously you can do, but if you want to attend a tutorial to get extra practice, these would be good ones to like wait, and you can come do those in tutorials. All right? All right. Colligative properties. Colligative properties. Why do we care about I? When you place a solute, remember the thing that is being dissolved, into a solvent, what is doing the dissolving, some of the solvent's properties can change because of the presence of a new particle. Those properties depend on the amount of solute present. Those are known as colligative properties. Now I have this little highlighted because it's important. The more particles a substance forms when it dissolves, or the higher concentration of solute present, the more change one will have in colligative properties. So there are several colligative properties, but the 2 that you need to be familiar with are boiling point, elevation. Boiling point, elevation. That's your boiling, increasing. And then freezing point, depression. TB increasing, TF or TM decreasing. So again, boiling point, elevation, freezing point, depression. What this means is that a solution made of a solid or liquid solute dissolved in a liquid solvent will boil at a temperature higher than the boiling temperature of the pure solvent, and will freeze at a temperature lower than the freezing temperature of the pure solvent. This right here is the whole reason why we put salt when it snows or ice. This explains why we use salt on our sidewalks on ice days. It causes the freezing point to lower. Did you know that? It's chemistry right there. So you can't ever say that chemistry is not in the real world. I know most of you probably don't like that they put salt, because then that means you're more likely to go to school. But that's why we do that. Also explains why you put salt in your water. Did anybody know? Who cooks in here? Probably not very many people. If you want your water to boil faster, you add salt. Obviously, it also adds flavor to the water. Then that flavor goes into whatever you're cooking. Potatoes, yummy. But that's why we do that, because it causes the boiling point to elevate. All right, so we're going to do some examples just talking about colligative properties and so on and so forth. So, would a substance with a I value of 3 or an I value of 4 create more of a change in the freezing point and boiling point of a solvent? And then it says to explain. Anish, what do you think? So I3 or I4? And why?
Because it has more particles in its wall, it has more change.
More dissolved pieces. So more change in TB, TM. Very good. MgCl2 is used more frequently to treat icy streets than NaCl is used. What could be the reason behind this? Let's go with Anurag.
Because when it dissolves, MgCl2 splits into more particles.
What is the I value for MgCl2? Okay. And what about NaCl? 2. So when you have this I value of 3, like he mentioned, more dissolved pieces, your TM melting is more. All right, I'd like for you to do this last example with your table. Ready, set, go. Last example with your table.
It
20 seconds.
Okay.
10 seconds. All right, Vishavi. Tell me what you in your table said. Explain. So, you're right about potassium hydroxide having an I value of 2. However, glucose would not have an I value of 0. What would it have an I value of? 1. Why is it 1? Remember right here. I know, like, this is not the same thing, but it is, right? It's going to dissolve, but it's not going to what? Dissociate, so it just has that 1 ion. So this is what you should have said, something like that, okay? And what's important, and I really want to emphasize this, there are questions that are very similar to this on your practice worksheet. And again, going back to the practice worksheet of, if this is not just, I'm just circling which one, it says explain. So I'm showing you how to answer these questions of telling me the answer and explaining, okay? All right. Now moving on to electrolytes. I talked a little bit about electrolytes last class when we talked about dissociation. But it's when will solutions conduct electricity? So an electrolyte is a substance that has been dissolved in water and has dissociated to give a solution of ions, which has the ability to conduct electricity. What allows this to conduct electricity? What is it that is conducting the electricity here when it dissolves? The ions, because what is an ion? An element with a, very good. So electrical conduction requires a pathway for the movement of electrons. Haven't heard that word in a while. No, actually, no, we used that word a lot last class. Movement of electrons, meaning we need charged particles that can move. There are several things that conduct electricity, but to be considered an electrolyte, the substance must contain ions. I highlighted this last part for importance. The more ions present, the better conductor the substance will be. Seems pretty self-explanatory, right? Okay, the more ions you have, more charges, okay, better conductor. Yes?
Is this when you can electrocute someone with Gatorade?
So, no. You'd be better off electrocuting somebody with something other than Gatorade. So that's, like, look right here. Many people know Gatorade as containing electrolytes. All that means is that it has dissolved dissociated ions. And so I think it's when we get to our acid base, when we do acid bases, in Miss Sapoka's class, you'll get to do this too because she'll be back. We have a lab, and we have these really cool tools that have like 2 prongs and it has a light bulb. And what you can do is you can make a bunch of solutions, and you put the 2 prongs in the solution, and based off of how bright the light bulb is, that's the stronger, if it's a strong electrolyte, it's going to be super bright, versus if it's super weak. Gatorade, the light bulb does light up, but it's very dim. So at least we know that the Gatorade companies aren't lying to you. There are electrolytes, but, you know, something that's stronger is going to be better. But we should be thinking about electrocuting people, you know. So I'm going to talk to you about different things that have electrolytes. So first, dissolved, soluble, ionic compounds are strong electrolytes when dissociated. They conduct electricity very well. However, when they are not dissolved, meaning they are a solid, they do not conduct. Why would that be? This last sentence. However, when they are not dissolved, meaning they are a solid, they do not conduct. Why is that? Diego. Yes, what else? They did not dissociate into their individual ions. Okay? So, next one. Strong acids and bases are strong electrolytes. Why is it that strong acids and bases are strong electrolytes? What did we say about strong acids and bases? What do? They fully dissociate. Whereas weak acids and weak bases are weak electrolytes. Why? Because they only partially dissociate. So they do conduct electricity, but it's very poor. So you're going to get like a very dim light. Okay? Melted ionic compounds and metals conduct electricity, but they are not dissolved. So they are usually not considered to be electrolytes. Again, melted ionic compounds and metals, they do conduct electricity, but they are not dissolved. So they are usually not considered to be electrolytes. Covalent compounds are never electrolytes. While some may dissolve, they do not form ions. They are called non-electrolytes. Again, I talked to you about sugar. Okay? You have sugar water. I put my probe in there. It's not going to light up. It's going to dissolve, but it's not going to light up. So that's always a way you could also think if you're like, is this salt water or is this sugar water? If you had one of those little probes, you could put that in there and it would tell you without having to drink it. Okay? Insoluble ionic compounds are never electrolytes. They do not dissolve, so they do not form ions. They are also called non-electrolytes. Okay? So it's pretty self-explanatory, straightforward, kind of goes along with what we did on the first page of things that do not dissolve, okay, will not dissociate, therefore will not be an electrolyte. Things that partially are an electrolyte, but they are weak. So you have weak electrolytes, strong electrolytes, and non-electrolytes. So you need to know that. So, first example says tap water will conduct electricity while distilled water does not. Propose an explanation for this difference. Okay? Well, what does tap water contain that distilled water does not? Minerals. Minerals. Well, what are minerals? What do minerals contain? Ions, right? So they contain dissolved ions. Okay, they contain dissolved ions. All right, I would like for you to do this example with your table. About 10 more seconds. All right. Vishnu, tell me what you said. Have a greater conductivity level because it has more what? More ions. Okay? Okay, so more ions equals a better conductor. All right, last little bit for today. So it says for us to fill in the information on the following chart. So ammonium carbonate. I'll give you a second to write down that formula, and then I'm going to call on somebody. Ammonium carbonate. Sanvi, what's my formula? What do I need around NH4? Okay. Sanvi, call on somebody to tell me if that's an acid, base, ionic, or covalent. Who? Hayden. Hayden, call on somebody to, it doesn't have to be somebody in our class if you know somebody. Not at your table, to answer the next part. I love hearing the papers wrestling. That means you're looking at your what? Very good. Very good. And Garima, call on somebody not from your table to answer this last part. And why did you say strong? Because it's ionic and it's also what? Soluble. So I wanted to go through this first one before I show you this little trick down here. Okay, so down here, I would write this down. It's just a little helpful way. So with ionic, we can have ionic be broken up into two things. Soluble and insoluble. Okay? When things are ionic and soluble, they are strong electrolytes. When things are ionic and insoluble, they are non-electrolytes. Okay? Concerning acids and bases, you either have ones that are strong electrolytes or weak electrolytes. That's dependent on if they're a strong acid or a strong base. Weak acid, weak base. And then finally, covalent, they are always non. Okay? That's just a little thing to help you, do those. All right, next one, copper to sulfite. Ariana. So this is telling you that copper has a charge of +2 and sulfite's charge is -2. So just CuSO3. Okay? All right, Ariana, call on somebody not at your table to answer the next one. Ionic. Adeline, call on somebody not at your table to answer the next one. Priya. Say it again. So it's not soluble. And then, Priya, call on somebody not at your table for the last one. Non. Very good. All right, I would like for you to do these next two. I'm going to put a timer on the board. Is what you should have gotten. HCl, acid. It's a strong acid, which means obviously acids are soluble in water. It's a strong electrolyte. Acetic acid, also known as what? Vinegar. That's your formula? Okay, it is a weak acid, so that means it's a weak electrolyte. Okay?